class we're going to do lesson on 3.2, parallel lines and perpendicular lines. So yesterday we went through corresponding angles, alternate interior, and same side interior. We said with those, we said if we have them, then we know alternate interior, corresponding angles are congruent, and then same side interior angles are supplementary. Today we're going to do the converse of that. So we're going to switch the statement up. So, for example, so here we go. First one, converse of corresponding angles. So yesterday we said if we have corresponding angles, they're congruent. Now we're saying if these two angles are congruent, then we have corresponding angles. So that's the first one. Number two, converse of alternate interior angles. So again, yesterday we said if these are corresponding angles, then or alternate interior, then they're congruent. Now we're going to say if these are congruent, if angle 1 and angle 2 are congruent, then we have alternate interior angles. And which means these lines are parallel. And then lastly, same side interior. If these add up to 180, then we know L and M are parallel. So we have those three. So we're doing the converse of them, switching the if-then statement. So we want to go ahead and prove. How can I prove, all right, 1 and 2 are, how can I prove that these are, or actually we want to prove, how can we prove that these lines are parallel? Well, let's start out with what's given. So always start out with our given statement. So we know angle 2 is equal to angle 1. How do we know that? It's given to us. So then we go to the next thing. What do you know about angle 3 and angle 1? So angle 1 and angle 3, they're equal to one another by vertical angles. So if you look at it, 2 is equal to 1, 1 is equal to 3. So now we can use our transitive property to say 2 and 3 are equal, and that'd be our transitive property. So now we can look at it. If we have 2 and 3 that are equal to one another, all right, then these lines are parallel by, these lines are corresponding, or those angles are corresponding, so it would be converse, right? The converse of corresponding angles. So we're working, using all of our logic as we continue on. So we want to go ahead and use that. So, by which ones can we use? So if I look at 1 and 2, how do I know 1 and 2, all right? Okay, how can I say which lines are going to be parallel based upon angles 1 and 2? Well, if you look at it, angle 1 and angle 2, they're inside these two lines right here. So if they're inside, what type of angles are these? They're on opposite sides. Those would be alternate interior angles. So we could say C and D are equal based upon the converse of alternate interior angles. Next one, 3 and 4. How can I prove that 3 and 4? Well, again, if you look at it, they're not inside this one, they're not inside these ones, okay? But they are on the same side. We have this line right here. They're on this line here, okay? So we're not going to even worry about this angle or this line here. So if you look at it, you have these ones, one on the inside, one on the outside. They're in the same kind of position. So we'd say 3 and 4 make A and B, since they're equal, A and B would be parallel by corresponding angles. Another proof. So if we have one line, so if A and B are parallel, and B and C are parallel, then we can assume A and C are parallel as well. This is kind of the transitive property at play. If two lines are parallel to the same line, then they're parallel to one another. Next, if two lines are perpendicular to the same line, then they are parallel to each other. And we could say if they're perpendicular, they both have 90-degree angles, so they'd be corresponding angles. So that would make our lines, that make them congruent and our lines parallel. So we want to go through this proof. So given that we have right angles, all right, RT, TS. So given that RT is perpendicular to T, so right here they meet at a 90-degree angle, and this meets at a 90-degree angle. So we'd state that. First thing is given. So then we know that angle 1 and angle 2 are equal. We know these are two equal because they're both 90-degree angles. That's a definition, all right? of perpendicular angles, that they're 90 degrees. So, next we know that R and S are parallel because what type of angles are those? If they're congruent, then those would be corresponding angles. Alright, so now we get to a little bit of the math part. So what type of angle? So we have this angle here, this angle here. We want these two lines to be parallel. So these would be corresponding angles, which makes them equal to one another. Then we'd subtract 6, divide by 2, x equals 17. Go to the next one. What type of angles are these? They're inside, they're on the same side, so they'd be same side interior angles, which means they're supplementary, add up to 180. So, combine like terms, negative 8 plus 62 is 54. Subtract 54, which gives us 126. Divide by 7, which gives us 18. So that is our lesson for today. We just did the converses of our statements. If they're corresponding angles, all right, then we have parallel lines. Now we're doing, so that was what we did. So with corresponding, same side, and alternate interior. We added 2 new ones today, but they're not. So if we have two lines are parallel to the same line, then those 2 lines would be parallel to each other.